Yeah. Good afternoon, dear students, and I hope this tutorial finds you in good health. And I'm also sure that by now you must have been able to have gone through the slide on correlation and then the lecture. So please, if you've not done so, please, I'm encouraging and enjoining you to do so. And secondly, the assignments which I gave in the last class, I would also be expecting you to finish it up and then pass it across. Remember, the deadline is still for 14th. So please make do to finish it up and then submit it. Now, having said that, today we'll be looking at something a little bit different from what we saw in our last class. We'll be looking at regression analysis. We'll be looking at regression, especially as regards to that is the social sciences. Now, when we talk of the term regression, I'm sure we must have been hearing that term before. This is not the first time we're hearing it. When we talk of the term regression, what does regression really mean? The dictionary meaning for the word regression simply means to step back or to go back. Now, regression is simply nothing but the measure of an average relationship between two or more variables in terms of their original units of data. Now, take for example, you have two variables. Let's take for example, height and let's say height and age. Or let's say for a business, let's look at variables like cost and what and revenue. These are two different variables. Now, attempting to find a relationship between these two variables is what regression helps us do. Please take note, it's a little bit different from correlation that we saw in our last class. It's a little bit different. One advantage that regression has over correlation is that with the help of regression, you can make forecast and prediction, as we are going to see in this slide. I mean, in this lesson. So now when we talk of regression, like I said earlier, like regression simply means, regression simply measures the average relationship between two or more variables. If it's just between two variables, the most better way of putting it is we can use what the simple linear regression. But if it has to do with more than two variables, three variables, four variables, and so on and so forth, then we're looking at multiple linear regression. Now, the term regression is attributed to have been of somebody known as Carl Gauss, as you can see on the slides here. And then the term regression was first used in the year 1877 by Francis Galton. Francis Galton actually conducted a study of the height of fathers and their children. And he found out something quite interesting, as I've pointed out here. He says it confirms that the average height of sons of a group of tall fathers was less than their father's height. That is, in Francis Galton's study, he observed that in relation to the height of their fathers, that is the sons which he picked for this study, the height of these sons, the average height of the son in comparison with the height of their father was a little bit less. On the other hand, when he compared the average height of sons whose fathers are short, he discovered that their average height was higher than that of their fathers. I will take that again. Francis Galton, in his study, observed that when comparing the height of tall fathers to that of their children, their sons, in this study, he observed that the height of these sons, the average height of these sons, was higher than the average height of their fathers. while the average height of short father, while the average height of sons from short father was higher than the height of their fathers. And this was what made him came up with a term called what? Regression of what? Regression to mediocrity. Because he observed that instead of these sons, instead of their height to be higher than the height of their father, the average height of these sons was what? Was lower than that of their fathers. So that was how he came up with the term regression. Now, in contemporary studies, when we use the term regression, we are looking at what two important factors. One is the dependent variable, and another is what is the explanatory variable. Now, the dependent variable is the variable that is explained, that is the cause for which is explained by the what? By the explanatory variable. Now, let me give us some more illustrations so that we'll get to understand. Now, take for example, if you're given two variables, like the son's height and the father's height, it is, you don't need a soothsayer to tell you that what that the dependent variable here is what is the son's height. Why the explanatory variable is what is the father's height? Because the height of the son is supposed to be dependent on the father's height. If the father has, if the gene of the father is what is of a very high height, on a normal circumstance, it is expected that the son will take the gene of the father, and as such, he is supposed to be what to be also taller. Another example is, for example, the height of the boys, and if you're given two variables like the height of boys and their age, you don't need to be told also that the height will be dependent on what? On the age of the boys. The higher the age, there's a tendency that what? The higher will be the height. So in this case, the height is a dependent variable, while the age is the explanatory variable, because it explains why the height is either tall or why the height is either low. Another example, as an economist, you must have come across the term consumption and disposable income. Now, you don't also need a soothsayer to tell you that an individual can only spend from their income. Take for example, if I earn an income of 10 naira, I can't spend 20 naira because I don't have that income. What I have is an income of 10 naira. I can't spend beyond that 10 naira which I have. So my income determines my what? My income determines my expenditure. It determines the amount of expenses I'm going to be making. So in this case, our personal consumption is your dependent variable, while your explanatory variable. Now, another example I'm going to be giving is, let's take for example the concept of demand and price. On a normal circumstance, you also do not need to be told that the demand is dependent on on price. The quantity that people will buy is dependent on the price of the commodity. If the price is high, automatically the quantity that will be demanded will be low. And if the price is low, of course the quantity that will be demanded will be high. So in this case, the demand is a dependent variable, while the price is the explanatory variable. So we can continue on and on. Take, for example, the crop yield and rainfall. Of course, the level of crop yield is dependent on the amount of rainfall. If you have good rainfall, you have good crop yield. If you have a very poor rainfall, if there is no rainfall, let's say they have less rainfall, and a case of drought, automatically the crop yield for that year will automatically be low. So a factor we are going to be dealing with as we look at regression proper is the dependent variable and the explanatory variable. Now, the next thing we're going to be looking at is like we pointed out earlier, that the regression shows the relationship between variables, and it is acclaimed to be one of the most commonly used tools in social sciences, in business analytics, in economics, and various fields of studies. Even in natural sciences, they make use of regression analysis. Now, another important factor that I would love to point out to us is that please take note, regression does not automatically mean causation. Now, what does that mean? Regression does not necessarily imply that what that, an, that a variable is caused by another variable. Now, let's take for example rainfall and crop yield as we saw initially. Now, rainfall does not automatically, it's not 100%, might not be the automatic cause for poor yield in a particular year. Take for example, if the crop yield in the year 2000, let's say in the year 2020, if the level of crop yield is very poor, it does not necessarily, when you use regression, it does not necessarily mean that what that it is caused by what by poor rainfall. There are many other factors that could lead to poor yield. I hope you're following. It could be as a result of poor climatic condition. It could be as a result of poor fertilizer. It could be as a result of the fertility of the soil and so on. So regression does not automatically mean what causation. The cause of a particular variable could be as a result of so many other factors. Another example, let's take for example in the area of the height of the children. There are other factors that could determine the height of a child. Doesn't necessarily mean what that if the father is tall, automatically the child will be tall. Now, another thing I would like to point out to us is regression and correlation. These are two factors, but they don't mean the same thing. Correlation would rather tell you if there is a positive relationship or if there is a negative relationship. While regression leaves you with it for you to be able to carry out numerous forms of see. It leaves you with the opportunity to be able to make forecasts. It leaves you with the opportunity to be able to outline which variable is dependent on the other variable. Now, there are different types of regression. We have the simple regression and the multiple regression, like I pointed earlier. Now, when you're dealing with just two variables, like we saw, like we've been seeing, when you're dealing with, let's say, uh, age and weight, age and height, when you're dealing with variables like price and demand, when you're dealing with variables like crop yield and what was it called? When you're dealing with crop yield and the amount of rainfall. Now, in such situation, you're dealing with what? Simple regression. Now, but when you're dealing with more than two variables, when you're dealing with variable 3 or 4 variables, like take for example, you're dealing with crop yield, you're dealing with amount of rainfall, and you're also dealing with the level of soil fertility, and so on and so forth. Now you can see in this case, you're dealing with more than two variables. So in such conditions, it's called what? Multiple regression. Now, the simple linear model, like we are seeing here. Okay, let's talk about the multiple regression first of all. In this case, you can see that that we have more than two variables here. When we have y, we say it's equal to, let's say this. Okay, sorry, let's continue. So back to what I was saying, I was making mention of the fact that if you take, for example, let's use let's use what we have here, for example. Looking at this, we have y here, which is the dependent variable. Let's say the dependent variable in this case is crop yield. Now, we could say it is dependent on what? On rainfall, which is, we can give the B1 value, the beta 1 value. It's also dependent on other factors such as what? Like rainfall, which we've given what? The beta 1. And then it could also be dependent on the soil fertility, which we've given what beta 2. We could also say beta 3, like the level of fertilization added to the soil, and so on. We give that one as beta 3, and so on and so forth. And then we have what we call the random error term, which in this case could be, we would explain more on this as we proceed when we begin to look at multiple linear regression in details. Now, the next thing is the simple linear regression. In this case, we are looking at just two variables. It could be just crop yield and what, and the amount of rainfall. It could be just demand and what, and the level of what, price. Now, in such case, simple linear regression, we give it a what, if an equation such as this, then we say y is equal to beta 0 plus what, beta 1x. Y in this case is the dependent variable. Y not is what is the intercept. I will explain that as we continue. Is what is the intercept plus beta 1, which is what the slope. The slope. And then what here, which is what the second variable, I mean the explanatory variable. So now, I'm sure that might be sounding wavy, but when we get into more detail this year, I believe you guys would understand much more better. So now let's look at a much more practical example. Let's take, for example, what we have here. Let's assume you're given a value like this. This is the level of alcohol. These are the levels of alcohol content. And then these are the levels of what? Calories. So we can see we have just two variables here. These are the levels of what? The levels of alcohol, maybe in a particular drink. And then these are the amount of what? These are the levels of calories. Now you could be asked to calculate what? The regression equation. It's just simple. Remember what? That every regression equation, as we pointed out here, should be what? Y is equal to beta value plus beta 1 to x. Now, in this, since you have been given the alcoholic content and then the calories, the number of calories, the first thing you have to do is to do what? Is to look for what? For the mean. You add up all these values. When you add it up and divide it by the number of what? The number of, there is 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 variables here. And then you divide it by 9, you will get what? 5.5166. Now, for this value, which is our x variable, when you add all the, which is our y variable, this is the x variable, this is the y variable. When you add all this together and then divide it by 9, it gives you what? 170.22. And the next thing you have to do is to take what? The mean deviation for your x variable. The mean deviation for your what? For your x variable. That is 4.70 minus your x variable, which is what? 5.55. Are we following? It will give you what? Minus 0.8165. You go to the next value, 6.70 minus 5.51. It gives you what? 1.1833. 8.10 minus 5.5166. It gives you what? 2.588. And so on. You continue it down up to what? 6.20 minus 5.5166. It will give you a value of 0.6833. Now, in the same way, you look for the mean deviation for your y value. These are your y values, that is the calories. You take what? The mean deviation for this. Remember, our mean is 170.22. Now, what you simply have to do is to do what? You begin to minus your y variable from the mean. We say 163 minus 170.22. You'll get what? Minus 7.2222. You do the same thing, 215, you say 215 minus 170.222. It will give you a value of 44.77. You do the 215 minus 170.222. It will give you a value of what? 4.7788. Now you do the same thing for the third value, 222 minus 170.222. It will give you a value of what? 51.777. The next one you do 104 minus 170.222. It gives you a value of what? Minus 66.2222. And then you continue for the rest variable, even up to what? 195. 195 minus 170.2222. That would give you a what? A value of 24.778. So you've gotten the mean deviation for this. Now the next thing you have to do is to do what? Is to raise your mean deviation. You raise it to the power of 2. You raise it to what? To the power of 2. Now in this case you say minus 0.8167, this value here, minus 0.8167 raised to the power of 2. It will give you what? 0.6669. You do the same thing, you say 2.58833 raised to the power of 2. It gives you a value of what? 6.6736. You do it for the third variable, which is what? Minus 1.3667 raised to the power of 2. It gives you a value of what? 1.8678. So you continue to do it for the what? Up to the last variable, which will give you 0.4669. Now you have to do the same thing for your what? For y mean value and mean deviation. You raise it, the value to the power of 2. That is, in this case, to begin with, we start with minus 7.2222 raised to the power of 2. That will give us what? 52.1605. You do the same thing for this, which is 44.7778 raised to the power of 2. It will give you 2005.0, so on. Now you continue it downward even up to the last variable, which will give you 6.3. And then when you add all this together for this, when you add all this together, it gives you what? 12.45. When you add all this together, it gives you what? 10,335.556. And then the next thing you have to do is to do what? Is to multiply the mean deviation of your x variable by the mean deviation of your y variable. When you multiply this together, you begin to get values like this. That is, take for example, minus 0.8165 times 5.8. It will give you, see, now you do the same thing for this. You say, let's take this again, minus 0.8167 multiplied by minus 7.22222. It will give you what? 5.8. 981. You multiply 1.1833 times 44.7778. It will give you this. Are we following? It will give you this. Now the next thing you have to do is to do what? Is to do the same for the rest of the variables. As you multiply these ones down, you multiply these ones by these ones, and then it will give you this corresponding what? These corresponding values. And when you add all this together, it will give you a value of what? 327.6667. That is your what? Your sum of squared of x on y variable. This is the sum of squared of x variable. This is the sum of squared of what? Of y variable. Now, having gotten these values, which are very, very crucial, now we return back to this our equation here. Remember, this is our equation here, which says what? Y is equal to beta naught plus beta 1 x value. We substitute, we begin to substitute. The first thing we have to do is to look for what? The beta value here, which is what? This. And to look for that, we simply say what? We simply say summation, the sum of on y divided by what? So x. And you just substitute the values here, which is, in this case, 327.667. You substitute it here. Divided by what? The sum of x value, which is 12.4, 12.45. And then you bring it down here. So when you divide this by this, it will give you what? 26.3. That means you've gotten what? This value. You've gotten your beta value. You've gotten what? This particular value. Now the next thing you have to do is to do what? Is to look for the intercept of this. That is the y-intercept. Now to derive that one, you simply have to say, you simply have to get the alpha value, which is what? Y minus your beta value, which you've already gotten. Now in this case, because we've already gotten our beta value, you simply begin to substitute again. What is your y? Your y in this case is what? 170.2222. So you bring down your what? You substitute it for y. Y, which is what? 170.22. You subtract it from your beta value, which is what? 26.3. Multiplied by what? By your x value. Remember, this is x here. And x is what? 5.516667. Now, when you it further, when you subtract it further, when you multiply 25.3 by this, and then you subtract your value from what? 170.22, you end up getting what? 25.0. Now, having gotten what? This value, you simply substitute your alpha value, which is 25.0. You simply substitute it into this equation. It becomes what? 25.0 plus what? 26. This is your what? Your value here into x. So to get the value of x at any point in time, what you just have to do is to do what? Is to substitute what the corresponding value here into this value, and then you get what? You get the value of x. Now let's see another example. Let's say you're asked to find the linear regression equation for the following set of data. This has to do with the age and the weight. This is what the age of a particular children or a particular set of child, and this is what the corresponding weight. When the child was 2 years old, the weight was what? Was 3 kg. When the child was 4 years old, the weight was what? 7 kg. When it was 6 years old, it was 5 kg. And when it was 8 years old, the child was what? 10 kg. Now you could be asked to find a linear regression equation for this. And to do that, what you simply have to do is to do what? This is a much more simpler way of deriving the simple linear regression equation. Now, the first thing you have to do, since you've outlined these values here, now you look for the what? You take the square root of what? You raise x to the power of 2. This is x, the age, and this is y, the weight. So you raise it to the power of 2. In this condition, you say what? 2 raised to the power of 2 will give you what? 4. 4 raised to the power of 2 will give you 16. 6 raised to the power of 6 raised to the power of 2 will give you what? 36. 8 raised to the power of 2 will give you what? 64. Are we following? Now you do the same thing for your y variable. 3 raised to the power of 2, of course, will give you 9. 7 raised to the power of 2 will give you what? 28. 5 raised to the power of 2, sorry. 3 raised to the power of 2 will give you what? 6. 7 raised to the power of 2 will give you what? 28. 5 raised to the power of 2, sorry, here it should give you what? 25. Rather, it should give you 25. And then 10. Let me make that adjustment so that it will be much more. Okay, so take that again. We said 3 raised to the power of 2. Let's begin with the x variable. This is our y variable. 2 raised to the power of 2 will give us what? 4. 4 raised to the power of 2 will give us 16. 6 raised to the power of 2 will give us 36. 8 raised to the power of 2 will give us 64. Now, moving over to what? To this axis, we have to calculate what? X times y. That is 2 times 3 will give us 6. 4 times 7 will give us what? 28. 6 times 5 will give us 30. 8 times 10 will give us what? 80. So when you add this up, it gives you summation xy. When you add this up, it gives you what? Summation squared. Now, the next thing we simply have to do is to do what? Is to use our formula. Remember, the regression formula, the linear regression equation is still y is equal to alpha plus beta x. Now, the first thing we have to look for is to look for what? For beta value. And how do we look for the beta value? Since we've solved all these out, we simply what? This is the formula for looking for the beta value. N into summation xy minus summation x into summation y divided by n into summation x squared minus summation x raised to the power of 2. So this is summation xy. We have summation xy here. Our n, first of all, is what? 4, because we have just 4 variables here. 1, 2, 3, 4. So that is what? 4 times, what is summation y? Summation y is what? 144 minus 20, which is summation x. This is summation x. Then we have summation y, which is what? 25. Divided by what? N again, which is what? 4, multiplied by summation x squared. Summation x squared is 120 minus summation x raised to the power of 2. This is summation x raised to the power of 2 is what? 400. When you divide through, it gives you what? 0.95. Now 0.95 becomes what? Our beta value, which is more like the slope. I hope you're following. Now the next one is what? Is to look for our what? Our intercept, which is denoted here by alpha. And the formula for deriving that is summation y into summation x squared minus summation x into summation xy divided by n into summation x squared minus summation x raised to the power of 2. When you substitute, summation y, of course, is 25, as you can see here, times 120, which is what summation x squared. This is summation x squared, which is 120, minus 20, which is summation x, times summation xy, divided by 4, which is n, into 20, into 120, which is summation x squared, minus 400, which is what summation x squared. Summation x raised to the power of 2. This is summation x, right? 20 raised to the power of 2 will give us what? 400. So that is it here. When you divide through, you get what? 1.5. Are we following? So in other words, we could say y equal to a alpha plus beta x. That is, y is equal to what? What is our alpha? Our alpha is 1.5 plus what is our beta? Our beta is 0.5x. Another way of deriving this, still using the same values here, we could use the same formula, the same pattern we used in the previous question. That is the same pattern we used here. The same pattern we used here. The same pattern we adopted here. We could use the same formula also to derive our value. That is this same formula here. Yes, this is the same formula. Then you can just simply say alpha is equal to what? Y minus beta x, x bar value. Now, that simply means we have to look for the mean for the x variable. For the x variable, the mean is what? 20 here divided by what? By 4. When you divide 20 by the amount of variable, which is 4, we'll get what? Our x bar variable becomes what? 5. Now, when you divide your y variable here, you divide it by what? By the amount of variables we have here, which is 4. That is 25 divided by 4. That gives us what? 25 divided by 4. That gives us this 6.25, which is our y bar variable. Our y bar here is the mean for y. Our x bar is the mean for x variable. So when you look for the mean, to get the mean for this y variable, you have to add up everything on this y bar, on this y variables here, and then you divide it by what? By 4, which is the amount of variable. 1, 2, 3, 4. That is 25 divided by 4 will give us 6.25, while 20 divided by 4 will give us what? 5 here. Now, you substitute further 6.25, which is your y bar variable, minus 4.75, which is what? A variable here. Remember, because when you multiply what? 0.95 times 5, 0.95 times 5, it gives you what? 4.75. So 6.25 minus 4.75 is equal to 1.5. Is equal to 1.5. Therefore, our alpha variable is still the same thing as what we have here, as this alpha variable here, which is 1.5. So, having gotten this alpha variable, once you begin to substitute, you minus this one from this, it will automatically give you what? Your 0.95 here, as we've gotten this one here, as you can see here. So, when you substitute it, it gives you what? This particular what? Y is equal to 1.5, which is your alpha or your intercept, plus 0.95, which is what? Which is your slope, as you can see here. Now, another important aspect of regression, as we pointed out earlier, is that with the help of regression, you can make forecast. Now, looking at this, let's say you're asked to look for what the age, what the weight of the child will be when the child is what? Is, let's say, 12 years age, is 12 years old, or when the child is what? Is 5 years old. As you can see, as the question here tells us to do, this is the part B of the question. It says, what will be the weight when the individual or the child is 12 years and when it is 5 years? Are we following? When it is what? When it is 12 years and when it is what? When the child is 5 years old. It's also quite simple. Since you've gotten your linear equation, which is this is your equation, which is y is equal to 15.0.95x. So what is our x in this case? The x is what? Age. You've been given the age of the child as what? As 12 and 5. Now you're asked to predict what the weight would be. So what you simply have to do is to substitute what? Your x, which is your what? Which is the age of the child. You substitute it with what? With this. To get the age of the child to get the weight of the child when the child is 12 years old, you simply would substitute it, multiply your slope here by 12, which is 0.95 times 12. It will give you what? 11.4. 1.5, which is your intercept, plus 11.4 will give you what? 12.9. So the child will weigh 12.9 kilogram when it is what? When it is 12 years old. Now to get the same thing when the child is 5 years old, you simply substitute. Since you'll be given 5 as the age, you substitute it here, 0.95 times what? Times 5, which is 4.75, plus the intercept, which is 1.5 here, it gives you what? 6.25. So the child will weigh 6.25 kg when it is what? It is 5 years old. So I don't know if you have any questions, but if there are questions, of course, you know the right channel to channel those questions to me. My WhatsApp account is always there. You can always, you can also chat with me through the MyCCU platform. Please feel free, ask as much questions as you have. I will be more than glad to answer those questions. Now, there's an assignment for you to do here. You are asked to look for the simple regression equation for these variables. This is what the weight of the person and the height of that person. The weight of persons and the height of this individual. Now with this, you are asked to look for what? For this simple linear regression equation. As we've done, can use any of the method we adopted, and then you look for what? For the simple linear equation. So thank you once more. Till I come your way next week, I'll be expecting those questions. And mind you also, the deadline for this is a week from now. So which means before our next class, it is expected that you have submitted these assignments to me. Thank you once more. Like I said, I would also be expecting our questions. So feel free to ask questions. Thank you. God bless you. And stay safe till I come your way next time.